Good morning. Okay, hope I'm audible and my PPT is visible. Today we start with project scheduling, right? And the word meaning is sufficient to explain what it is all about. Uh, since whenever you are taking up a project, it is very important to decide the deadlines associated with the project. How much time do you have to complete the project? How many resources do you have to complete the project? Right? How can you do it in the best possible economically feasible manner without, or rather, I would say, maximizing the profit, right? And you don't run into trouble of overshooting your budget or underutilizing your resources or crossing the time limits of delivery and all those kind of delays in the starting of the project. Now, over a period of years, what has happened is the time taken to develop the project. That means the gap between you getting an order and delivering the product. You had sufficient time. Of course, technology was not as powerful as it is today, but within the limited resources, you had substantial amount of time to deliver your goods. But today, that is not the scenario because we have understood that computers are just a tool and we know what they are capable of. Not only the developer, the end user is also capable of understanding all these technology terms, etc. Now, remember earlier, on one side, you had people who were conversant with technology, and on the other side, you had people who were not at all conversant with technology. They only knew their job. They had domain knowledge, but not technical knowledge. And on the other hand, you had people with technical knowledge, and most of the time did not have any domain knowledge. So many projects primarily failed because of this gap. That means neither people were understanding what you're talking about, both sides, right? The domain knowledge, the workers never understood, the users or end users never understood what you are talking about. And you many times did not understand what they are talking about. So there was a huge gap. And in those days, understanding this, then correcting it again, trying to understand, correcting, the whole cycle would take a lot of time. But as I told you, we were not so dependent on technology, and that was the reason why we had sufficient time to implement these kind of things. But today we are all walking on deadlines, right? You have to complete something within the stipulated time. Now, why do you have to bother about this? If you ask, one is you have limited resources. The resources have become expensive, and unless and until you utilize it to the maximum, right, you may incur loss. You may cross your budget. You may cross the deadlines. You may underutilize or overutilize your resources. When you talk about overutilization, you're actually dealing with interpersonal relationships. They can be strained because you are giving them unrealistic deadlines and people are not able to complete it. Then the whole atmosphere gets into trouble. So the whole task of project scheduling is very important. A good project manager will be able to schedule things in such a way that it is acceptable to people, realistic in nature, and so on and so forth. Right? Okay. So a project scheduling is a process of deciding how to work in a project will be organized as separate tasks and when and how these tasks will be executed. Very simple. You estimate the calendar time needed to complete each task, the effort required, and who will work on the task that has been identified. You also have to estimate the resources needed to complete each task, such as the disk space required on the server, the time required on specialized hardware, such as a simulator, and what is the travel budget will be. These are just one or two or three things. There could be hundreds of parameters in a project. Some things you might outsource, so you're dependent on them. So that matters how much you're paying them and how fast they're giving you the product. Are their delays causing problems for you? Right? So you have to put pressure on the supplier. Then people moving out of the project, right? People resigning from the company, people sick, and you had scheduled everything properly with the limited resources you have, and suddenly there are two people who fall sick. What do? You cannot extend your project at all. So you need, so that is a kind of what you call, I would say, very intricate, complex task called project schedule. And a lot of this is there documented, but I would say again, 70% depends on the experience of your project manager. Because the more experience you have, you will be able to come up with solutions very fast. Theory doesn't help everywhere. Theoretical discussions are basically on certain figures and facts. Agreed. But in real life, things do change a lot. Like they say when you buy a bike, they tell you mileage is so much, but do you ever get that mileage? Why? Because it's not the problem with the bike. It is the problem with the traffic. It is the problem with the roads, right? It is a problem with how you drive it, how good a driver you are. Your own bike, the same bike, if driven by three different drivers, will give you different performances. That depends on the experience of the driver. So experience does matter in these cases. I would say they matter more in these cases because those are the only what you call uh, people who can actually contribute to exactly how things are going to go. Even before the project starts, an experienced person will know what all could go wrong, where all it could go wrong, when all it could go wrong also, to be precise. So he will be mentally more prepared. And when he schedules a project, he will keep all these points in mind. Nobody has to tell him. He keeps all these points in mind and then progresses accordingly. But a lesser experienced person won't know what could go wrong. He will learn that only after carrying out the project scheduling of 3 or 4 projects. And more the projects he handles, naturally more the experience will be. A person with 2 years experience, a person with 5 years experience, a person with 15 years experience makes a lot of difference in how they handle project scheduling. Of course, that should be a good learner also, right? Just because you did the same job for 15 years without any productivity doesn't help. You should be involved in the process. You should be able to provide solutions in proper time. You should be able to handle crisis also. That is also very important. If something goes wrong, how do you make sure that things are going as per schedule? It is not enough that you just plan. You need to monitor it. You need to confirm that it is happening according to plan, etc., etc. So many issues related to all this. Now, project scheduling activities. What are the various activities related to project scheduling? One is split the project into tasks and estimate time and resources required to complete each task. Everywhere we learn about breaking down the bigger problem into smaller problems, right? Here also the same rule applies. Divide your project into preferably independent tasks because dependent tasks can be handled only in sequence. Independent tasks can be handled in parallel also. So you should be able to clearly identify whether some tasks are dependent on other tasks or they are not dependent on any of the tasks. There will be always a mix of both types, that is sequential and parallel. So you should be able to clearly identify all these things. Again, experience counts a lot in that. So once you have that, then you are basically ready for scheduling a project. Organize tasks concurrently to make optimal use of workforce. Which all tasks you can carry out at the same time, do it. Don't wait for everything to be done one after the other. Say you are having only 5 people. So you plan your schedule in such a way that these 5 people do tasks one after the other. That should not happen. If you can have multiple tasks that can happen together, then that is the best way of doing it. Say, for example, look at a metro construction. There might be 1,500 pillars spread across the city. If you have observed, you will see that it is not that they start from pillar number 1 and then continue 2, 3, 4, 5, 6, 7, 8. That might take a lot of time if you are going by that sequence. Because on an average, one pillar construction might take 2 to 3 weeks. The foundation itself will take 2 weeks. Then building the rest above that will take another 2 weeks, probably a month for a pillar. So they don't complete, they wait for completing the first pillar to start the work on the second pillar. So what do? Construction of the pillar, they divide into various tasks. Now, what are the tasks related to the construction of a pillar? First is digging deep holes into the place. Then, so that will be done by one team. They are specialized in that, excavating. So they pull out the mud, the slurry, everything, and then move it to some safe place, wherever they want. Then the next team, parallelly, they start creating iron frames, which are to go down into the concrete there. That parallelly happens. As these people are digging, the work happens there. The moment the digging work is over, they move on to the next pillar and start digging there. And these people lower the iron frames into the holes. Once that job is done, they move. By the time the other second pillar digging will be over, they will move to the next pillar to create iron frames and then put it down there. But the moment these iron frame guys move to the next pillar, they will start filling it with concrete. So see how tasks are handled. They don't wait for each task to be over and they will complete the first pillar and only then they will start with the second pillar. Now that is going to take a lot of time. So this is an example, typical example of a project scheduling. This is applicable everywhere, right? Even in your day-to-day activities, you can plan accordingly. You don't have to always wait to finish the first task to complete complete the first task to start the next. No, if it is possible, if you can start, definitely start it. Many of us, what we try to do is we try to do the whole thing ourselves. You can always delegate it to somebody else. You could be in control because you might be more experienced than others. So you could be in control, but the basic tasks, you could always hand it over to somebody else. So split project into tasks and estimate time and resources required to complete each task. Organize tasks concurrently to make optimal use of the workforce. So wherever possible, organize your tasks concurrently so that your manpower is used completely. Nobody is sitting idle in the project. Minimize task dependencies to avoid delays caused by one task waiting for others to complete. Whenever you divide it into tasks, make sure that they are not interdependent. The problem comes when they are dependent. You cannot start the second task without completing the first task. So organize things in such a way. Then depend on project managers' intuition and experience. This is what I said, experience matters a lot. All these activities, though they are theoretically and numerically framed and documented, nothing like experience. And experience will definitely make all the difference in project schedule. Remember that. I would say, even if you don't have any clue, an experienced person, when he comes up and takes the project, without looking at any document, he can actually plan how things have to go about, which he has learned from experience. Nothing to replace that. Today, many of the projects get into trouble primarily because we don't value experience. We just value theoretical frameworks, which is not always right. We spend a lot of time during using documentation, etc., which actually affects our basic productivity itself. We don't get that much of time to sit and concentrate on the work that we are doing. What affects us is the other way around. Now, milestones and deliverables. Milestones are points in the schedule against which you can assess progress. For example, handover of a system for testing. So at each stage, now, like I told in the metro construction, digging, excavation, that is a milestone. Putting up iron frames, that is a second milestone. Filling it with concrete, third milestone. For each pillar I'm talking about, there are deadlines put across. Deadlines are normally dependent on the milestones, what you want to achieve in that specified period of time. That is your milestone. How much time it will take is something which you learn from experience. And that can change also. The first pillar might be you completed in 2 weeks. The second, due to some reason, might take more time. So you need to be prepared for some differences here and there. Because when you started excavation, you found that there is a rock beneath. So then the whole concept changes. You may not have to go deep because the rock itself is capable of handling the concrete pillars. So you just need to plan and understand. You need to probably do a study there just to understand how much of rock is there in that area. If all 4 pillars can be put on a rock, then well and good. Then another thing is you might also understand the strength of the soil there and the rocks also. Because if the rock is brittle, if you go and fix the pillars on that, tomorrow for some reason of natural calamity, these rocks could break. But if you feel that it is solid rock, granite, which will last, then you can actually plan accordingly. Right? So you have milestones there, right? Completing each task. And everything goes as per that milestone. Like I said, excavation, iron frames, concrete, then the pillar upwards, then the girder that holds the metro rail, what do you call, bay on the top. Deliverables are work products that are delivered to the customer. Example, a requirement document of the system. Now this actually, though you say deliverables, it is based on what the user has asked for. The user tells you what he needs and you plan deliverables accordingly, right? And sometimes what happens is, though the user said, you might have your own outputs additional to what the user had said. Now that also can be communicated. See, no system is developed exactly based on user requirements. They always try to get something more out of it. Software that way has helped a lot, at least towards later stages. Initially, it was kind of automation. That means whatever you're doing manually was done with the help of a computer. That's all. You never looked at additional possibilities of how to use data. Now, that is what we are doing today. Data mining, data warehousing, not today actually, that started long back, right? How you can utilize, there is so, when you started finding that there is a lot of data lying there and processing is becoming so easy, why not try to find some meaning in the data? That is where I told you data warehousing, data mining, then business intelligence, what you call, right? And today we are using, now all those things were done manually using certain tools like Excel or R software or something like that. But today we are going to the next level where human intervention can be minimized by the use of AI and ML, machine learning, which is actually going to revolutionize how business is done. But somewhere down the line, I personally feel that we are losing the human element of it because these are all abstract systems. They work on formulas and standards. But human life is not like that. Human life is our mood itself. Just imagine, let's look at it. Today you are writing an exam. You did not do well. Tomorrow I give you the same question paper and ask you to write the exam. You might do well. Possibility, I'm telling you. Because yesterday you were mentally not fit to write an exam. I'm not talking about people who don't study and then try to write exam and perform. Those people, the next day also, they are going to be the same because they have not changed. But for a person who has actually studied properly and prepared for the exams, I wouldn't say studied, he is prepared for the exams, right? He might perform better the second day, or he might perform the better the first day, and the second day probably the same with the same question paper. He is not to perform accordingly because his mindset is not proper for the next day. So mind, thought process, etc., can make a lot of difference in the output we generate. Right? You can't expect the same output from the same person all the time. It keeps changing. It keeps fluctuating. That is because we are built for that. And that is why we say between natural intelligence and artificial intelligence, the primary differentiator is emotion, of course, EQ, emotions. Natural intelligence is affected by emotions, positively or negatively. But in the case of artificial intelligence, there is no concept of negative intelligence. It is always possible because it is simply working as a machine. That's all. It's doing the task. There is no emotions attached to it. Maybe in the next level of AI, even robots could behave on an impulse, or robots also could be moody. Then you can say that we have achieved natural intelligence through artificial intelligence. Till then, no, because human dynamics is completely different, right? Okay. So remember, whenever you say deliverables, it is actually a requirements document for the system. Now, how do you decide upon the deliverables? You go to the user, understand his requirements, and that is going to be your deliverable. You are going to do software for him or a system. You are going to develop a system for him. So deliverable is primarily what all he has asked for and when you are going to give it, how you are going to give it, right? Now, project scheduling process. Primarily, first identify the activities that is based on software requirements and design information. You should all be familiar with that. Then identify activity dependencies just to see whether it can be done sequentially or parallelly and so on. Then estimate resources for activities, allocate people to activities, create project charts, and then go back again. Once the whole task is over, then you can also have bar charts describing the project schedule. Now, this is kind of a cyclic thing. Estimate resources for activities, allocate people to activities, create project charts. If the project is over, you stop there. Otherwise, you go back to, again, re-estimation of resources, then reallocation of people, and then creating, again, fresh project plans. Because it always doesn't mean that the first plan that you create will work. Sometimes you might have scheduled it in such a way that it takes more time. Sometimes you might have scheduled it in such a way that it takes lesser time. Right? Only when you start working, you will realize that, yes, this task, though I said 10 days, could be completed in 6 days. So the moment I complete the part in 6 days, I can completely reschedule my project. I'm getting 4 days of bonus there as per the previous project plan. So projects can get compressed as you do it, or it can get elongated also, otherwise also. Because I planned for 6 days, but only when they started doing, I realized that it will take 10 days. So I have to replan everything, reschedule everything. So these kind of activities, it is not that you plan everything. Of course, as you become more and more experienced, then the number of changes will get reduced. Because in the beginning itself, you will be having a clear-cut idea about how much time each task takes. Now, scheduling problems. Estimating the difficulty of problems and hence the cost of developing a solution is hard. Productivity is not proportional to the number of people working on the task. Right? So one is estimating the difficulty of problems and hence the cost of developing a solution, which is very difficult because you cannot evaluate a problem because it is very much situation dependent. Right? And hence the cost of developing a solution is very hard. So because you cannot actually evaluate things, then deciding about the cost becomes very difficult. Now, productivity is not proportional to the number of people working on a task. Adding people to a late project makes it later because of communication overheads. Adding people to late projects make it later because of communication overheads. Now, what is the meaning of this statement? Now, before that, let me explain this. I think I left it out. Productivity is not proportional to the number of people working on a task. Always remember that. It doesn't mean that if you have got 10 people, you will be able to do the work faster. There is a saying called too many people spoil the broth. Too many cooks spoil the broth. So more the people, faster the solution doesn't work anywhere. Many times lesser the people, there is more efficiency in the work team, and thereby you'll be able to complete the task much faster. Right? Okay. Now, so productivity is not proportional to the number of people working on a task. So two here, one here. Then adding people to a late project makes it later because of communication overheads. Now, suppose you feel that halfway through or towards when the 75% project is complete, you feel that you won't be able to meet your target. Then the immediate solution that comes to an inexperienced person is let us increase the number of resources. Let us increase the number of people to complete the task faster. Most of the time, this does not work because suddenly when you have some new people coming into a project in between, they have no clue about what is happening compared to the people who have been involved in the project from the beginning. So then what happens is it takes more time rather than planned because you have to communicate these things to these newcomers first. So don't ever do the mistake of adding people. Even if you are badly needed, try to add only the minimum number of people to your system. So that is the meaning of the slide. Then the unexpected always happens. Always allow contingency in planning. Don't expect to everything to go smoothly. Being a project manager, you sit and prepare a schedule. Never assume that things will go as per your schedule. Always be prepared for the worst. So that is where we say you need a plan B also. Again, experience helps a lot in handling this situation very much because the more experienced you are, you will be able to find out what could go wrong when, and you will be prepared for that mentally at least. You know how to solve that problem. So you will be able to take immediate steps accordingly. Right? Okay. Now, schedule representation. Graphical notations are normally used to illustrate the project schedule. These show the project breakdown into tasks. Tasks should not be too small. They should take about a week or two. Right? So one is graphical notations are normally used to illustrate the project schedule because graphical notations are always easy to understand rather than you describing things. And when you describe the problem is people take their own meanings to what they read. Whereas if it is graphical output, the idea is clearly conveyed across. Now, these show the project breakdown into tasks. Tasks should not be too small. It should never be too small. They should take about a week or two. Then bar charts are the most commonly used representation for project schedules. They show the schedule as activities or resources against time, right? So bar charts are the most commonly used representation for project schedules. They show the schedule as activities or resources against time. Now task duration and dependencies. Now task T1, effort percentage is 15. Time duration is 10. No dependencies. T2, effort is 8 days, but duration is 15 days. No dependencies. T3, effort is 20, duration is 15 days. Dependency is on T1, right? Effort T4. So this chart basically tells you how much effort it takes for each task, how much duration, number of days it takes, and then if there is a dependency or not. So for example, T5, if you look at it, there is dependency on T2 and T4, right? Effort is 5% days, but duration is 10 days. Now, activity bar chart. See here, T1, T2, T4, they don't have dependencies. That means they can be started together. They start on week 0 itself, right? This takes 2 weeks. This takes 3 weeks. This takes another 2 weeks, right? Now T3, if you look at it, T3 dependency is T1. So once T1 is completed, you can start T3. That is the reason why when the moment T1 is completed, you start with T3. Same here, T5, dependencies on T2 and T4. So the moment T2 and T4 is completed, you can start with T5. So this chart tells you how and when you can start each task. Now staff resource allocation chart. Each person is in task 1. So you know how much time he is needed for that. Based on that, you have dates here, 4, 7 and 19, September. So it starts on 4th of July and ends on 19th of September. So there T1, Jane is assigned to task T1 from 4/7 to completion, probably somewhere here. Then he moves to T3. She moves to T3. After 1/8 or probably somewhere here in between, that is, let us assume it as 4/8, T9 starts. So Jane is moved to that side. So you can see how each person is allocated for each task. So that also is actually charted. By looking at this chart, people can understand when you are supposed to join which date, which task. Now, project scheduling using a non-activity on network diagram. Now, scheduling. Time is nature's way of stopping everything happening at once, right? Having worked out a method of doing the project, identified the task to be carried, assessed the time needed to do each task, need to allocate dates, times for start and end of each activity. Things we have discussed already. We're not going to explain that once again. Now, activity networks. Now, this is something new. Assess the feasibility of a planned project completion date, right? So when will you be able to complete it? And is it feasible to complete it within that specified period? That is something you have to assess. That second one, identify the resources, when resources will be needed to be deployed to activities, right? Then calculate when costs will be incurred. Then this helps the coordination and motivation of the project team. So one is feasibility of the planned project completion date, whether you have scheduled a deadline as 19 September, but is it possible to do it on that day? Is completed on that day? Then identify when resources will need to be deployed to activities. So when all do you really need what all resources for deployment of various activities? So you can prepare plans accordingly. Calculate when costs will be incurred. When these expenses will be incurred in that particular project. This helps the coordination and motivation of the project team. Defining activities. Activity networks are based on some assumptions, right? A project is composed of number of activities, may start when at least one of its activities is ready to start, completed when all its activities are completed. Now, these are the assumptions. One is every project is composed of so many activities, then it may start at least when one of its activities is ready to start, and third one is completed when all its activities are completed. Defining activities continue. An activity must have clearly defined start and end points. So whenever you say an activity, it should have a beginning and it should have a end. That should be clearly defined. Otherwise, you cannot say it is an activity. Must have resource requirements that can be forecast. These are assumed to be constant throughout the project. So whenever you say an activity, you must be able to say beforehand when, or rather, what is the resource requirement of these required to complete this project. Must have a duration that can be forecast, right? that may be dependent on other activities being completed first, precedence networks, right? That also is something which you have to understand. May be dependent on other activities being completed first. So is the current task dependent on the previous task, right? Identifying activities. One is work-based. Draw up a work breakdown structure listing the work items needed. Then product-based approach. List the deliverable and intermediate products of the project. Breakdown known as PBS. Product breakdown structure. Identify the order in which products have to be created and work out the activities needed to create the products. So if you list this, one is work-based. Draw a work breakdown structure listing the work items needed, or the second is product-based. What is it that is going to be delivered at each stage? So based on that, you you identify activities. Now, hybrid approach, a mix of both. You take a project, you have an installed system, software components, right? So you have an installed system, software component, user manuals, then training course. In installed system, analyze the requirements, outline the design, detailed design, integrate the system, test the system, deliver the system, user testing. In software components, review the requirements because your development is going to be based on the requirements. Then outline the design, detailed design, code the software, test the software. User manuals. Analyze requirements, design manual, write text, capture screens, do page layout, print manuals. Then training course. Analyze requirements, design the course for that particular project, write a manual for that, print handouts, and finally deliver the course. So for each project, you have got one is the install system, the software component, the user manuals, and finally training the people who are going to use it. Final outcome of the planning process. A project plan as a bar chart can be Andy is going to work for the first week, right? Then she will continue with probably the second week and the third week and the fourth week. At the same time, Bill can start working on a task E after 3, the second week. And Bill will continue with that work till he completes task F. Then Charlie starts working on the activity immediately after the third week. Right? Probably it has got dependency on A, B, and C. And so that's why after C, see here, Charlie starts working on activity G. Then H, which is probably after F task, can be done only after F task. And after all the tasks here, you have system testing. So only after everything is done, you can start testing the system. That is why you can see when after the 9th week, when you start this activity called I, which is nothing but system testing, all the basic activities are over. So your system is actually ready for testing. Activity on node diagram. Do A, after which you can do B and do C. B and C can be done parallelly, after which you can do D. So do D is dependent on B and C. So only after these two processes are complete, you can start working on D. Drawing up a activity on network, a node diagram. No looping back is allowed. So at no stage you can, that means there is going to be only progression. Never you are going to come back. So you must plan it accordingly. No looping back is allowed, right? Deal with iterations by hiding them within a single activity. So if at all some iterations are there, let it be inside an activity. Activity should not be looped back. Then milestones. Activities such as the start and end of the project, which indicate transition points. They have 0 duration. So activities such as the start and end of the project which indicate transition points, they have zero duration. They are called milestones. They'll be either at the beginning of the project or the end of the project, and they don't have duration as such because they are just markers, just to tell you that. Now, lagged activities, where there are a fixed delay between activities. Example, 7 days notice has to be given to users that a new release has been signed off and is to be installed. So after acceptance, after 7 days of acceptance testing, you are going to install it. So these are called lagged activities. You are forced to lag it. Your work might be over, and you cannot plan your implementation unless and until your work is over and tested for proper functioning. So after everything is over, you give 7 days time. You tell the people that, yes, we are ready. Within 7 days, we'll be moving on to the new system. So that is called lagged activities. Sometimes you'll have to forcefully delay things. Types of links. Now, for example, best example, I can use trains. See, most of the time what they do is if one train is late, which is okay to manage the train, what they do is they make that train wait and let others pass by so that they are not delayed. Otherwise, what will happen? If you wait for this train to move and then release the other trains, the train delay caused by that particular train will affect other trains also. So here what they'll do is they will probably put that train on one station and release two trains which are coming close by so that they will pass away on right time. Then they will move this train probably to the next station or the next station until the following train comes. And once that is coming, they will stop this train in one of the stations or even the outer of the railway station, leave it there, and then release the other train. So that the delay in one train will not affect the timing of the other train. So everybody moves accordingly. Now, types of link between activities: finish to start, software development, acceptance testing. Now, this is the link. Start to start, finish to finish. You start with the activity, right? Then test prototype. If it is okay, you move. Otherwise, you document amendments, what changes are to be made. And then you also look at before and after part of it. And then you move to finish. Now start to finish. Operate a temporary system. Acceptance test of a new system. Once the acceptance test is done, you implement it to cut over a new system. During this process, you can actually have a temporary system in place so that if something goes wrong, it does not affect the complete functioning of the organization. Start and finish times. Earliest start, latest finish. Latest start, earliest finish. That should be the approach. If you start early, you have sufficient time to finish late also. But if you start late, then you try to finish at the earliest so that the activity time remains constant. If at all there is spillover, very negligible. Now, activity report, write report software, earliest start is yes. Earliest finish is EF is equal to earliest start plus duration of time. Right, that means when you started plus the duration of time required for that activity. Latest finished, latest task can be completed without affecting project, and latest start is equal to LF hyphen duration. Example, earliest start day is 5, latest finish day is 30, duration is 10 days. What is earliest finish and latest start? Float is equal to LF minus ES, latest finish minus latest start minus duration. Activity on node notation. Day 0. Day numbers used rather than actual dates. So this is a convenient way of using, because many times what happens is if you put dates, people will have that mindset 10th of August or 10th of November, right? If you say 10 days from now, they are not bothered about the date. They just start counting the dates. So there, if you look at it, by practice, it has been observed that telling the days is much more effective than the number of days. When you say you are given 10 days from today, you actually start working properly to complete it before the 10th day. But when you say it is on 10/9 or 10/10, then you look at the date. You now don't count the number of days. So what happens is you will not be able to relate the work with the time frame. So it's always better to use the day numbers. Then make initial calculations easier, not concerned with weekends and public holidays, right? For finish dates / times, day one means at the end of the day one. For a start date / time, day one also means at the end of day one. The first activity therefore begin at day 0, that is the end of day 0, that is the start of day 1. Activity on node notation: earliest start, duration, earliest finish. Activity label, activity description. Latest start, float, latest finish. Complete for the previous example. Earliest start is equal to day 5 by earliest finish. Latest finishes day 30 minus divided by latest start. Duration is 10 days. Forward pass. Start a beginning day 0 and work forward following the chains. Earliest start date for current activity is equal to earliest finish date for the previous. When there is more than one previous activity, take the latest earliest finish, right? So when there is more than one previous activity, take the latest of the earliest finish. So basically means the task that finished is the latest, but the first one to finish latest. Example of an activity network. Start. So hardware selection 6 weeks, install hardware 3 weeks, after which you can go to install and test 2 weeks. Start 4 weeks software configuration, 4 weeks data migration, and 2 weeks install and test finish. 10 weeks for recruiting the staff, 3 weeks to draft office procedures, then 3 weeks for user training. So every task is planned how it goes about. And in some cases, you can bypass recruit staff. And if they are not permanent employees, you can bypass this office draft procedure. You directly go to training. Or if they are experienced also, the same applies. Right? 1 minute. Forward pass. Activity, earliest start, duration, previous activity, earliest finish, latest start, and latest finish. Hardware selection, earliest start is 0, it started right away, duration is 6, earliest finish is 6. System configuration, duration is 4, earliest finish is 4. Install hardware 6, earliest start, duration is 3, previous is A, earliest finish is 9. Data migration, earliest start 4, duration is 4, 3 is B, and earliest finish is 8. Draft processes, earliest start 4, duration is 3, previous is B, and then earliest finish is 7, and so on and so forth. So each task, the details of each task is listed in this table. Now that chart which actually help you to understand which is finished, which can be finished earlier and later. Again, now LS for all activities, latest start for all activities. Now the chart has been redone to understand what is the latest start provision for each activity. Backward pass, start from the last activity, latest finish of last activity, earliest is equal to earliest finish. Work backwards. Now that is another approach, right? Latest finish for current activity is equal to latest start for the following. More than one following activity minus take the earliest LS. Then latest start LS is equal to LF for activity minus duration. Again, it's a similar chart representing that, right? You are completing the table, filling up the latest start and latest finish columns also. Now float. Float is equal to latest finish minus earliest start minus duration. So earliest start, this is the float area. That means the area time where you get to adjust yourself. Then you have the latest start here. You cannot go beyond this, and the earliest finish. So you have an earlier start, maybe you will finish it here. You start late, you finish at this point. But then that is taken care of by the buffer time provided, which is called float. Now compute activity float. Again, the same floating time, how much you need for that. Earliest duration is 6, earliest finish is 6, latest start 2, latest finish is 8, because 6 plus 2, 8, right? And the float remains 2. Same with this one also. System configuration. Duration is 4 weeks. And then latest start is on the 3rd week and latest finish is on the 7th week. 4. The duration here is, sorry, the float here is 3. Latest start and latest finish for activity. The same chart represented again using the latest finish and latest with the float consideration. Next is critical path. Note the path through the network with 0 floats. Critical path. Any delay in an activity on this path will delay the whole project. So that is called the critical path, the most important path in the project movement. So if you any delay on that activity chart will definitely affect the whole project. There will be at least one critical path for each project. So every project will definitely have one critical path. A free and interfering float. Now see here, 0, 7 weeks, 7, task A, to latest start, latest and all that. You can see B can be up to 3 days late and not affect any other activity. This is called free float. B can be further 2 days late, affects D, but not the project end date. Interfering float, what you call. So there are some, even if they change, they will not affect the other activities. And there are some delays. Even if there is a delay, it may affect the next task, but it will not affect the whole task, right? Because float to a certain extent will take care of that. Then comes resource scheduling. Resources, people, equipment, hardware and software tools, materials, physical infrastructure, support services. Resources, human resources, hardware and software tools, physical infrastructure, network, desktops, support services. Time, elapsed time can often be reduced by adding more staff, members, groups law. Money used to buy the other resources, non-human resources. Resource allocation. Identify the resources needed for each activity and create a resource requirement list. Identify resource types. Individuals are interchangeable within the group. Example, Java programmers as opposed to software developers. Allocate resource types to activities and examine the resource histogram. So how do you utilize your resources? That comes under resource scheduling, so that you don't have too many resources assigned to a particular project and then lying useless there, which could probably be used for other projects. So if you plan it properly, you will be able to allocate your resources at the right time, at the right place for the right work, where thereby maximizing the resource utilization. The objective of most project scheduling, especially in the software industry, I would say is resource utilization. Resources should not be idle. Resource histogram. Staff required weeks. First week you require 2 staff. Second week you require 3 staff. Third week you require only 2 staff. Fourth week you require 4 staff. Fifth week 2 staff. Sixth week. So this is the cutoff line, what you call an average timeline resource share. Now, except for specialists, most team members are fully loaded for the duration of the project. Now, specialists will come and go whenever required. Other people are there in the project continuously. They are needed there, right? Say, for example, if you go to a hospital, there are certain consults. Smaller hospitals always have consultant people, doctors. They come on call, but they have basic staff like nursing staff, emergency handling, care, staff, etc., who are permanently there. Now, they maintain that balance because they might not be able to afford specialist doctors. So they are on call. So whenever required, primary activities are handled by the doctors, junior doctors there, and they will immediately refer the case to the senior doctor who will come there and carry out the task at their leave. So that is why here also, except for specialists, most team members get fully loaded for the duration of the project. It is usually difficult to get specialists who will work odd days to fill the gaps. Need for staff to learn about application, etc. Members often have to be employed for a continuous block of time. Otherwise, they will lose interest. Right? So when you have people, you must keep them engaged. Desirable to employ any constant, desirable to employ a constant number of members on a project who are, as far as possible, are fully employed. Project managers in consultation with program managers to work out the schedule. Sometimes we have had to add another week of resource leveling. Sometimes we may need to add another week additional just to balance the resources, right? So that it doesn't affect our cost, but doesn't affect our efficiency also. Now, prioritizing and handling resource conflicts. How do you understand which task is having more priority? And based on that, how do you handle your resource conflicts? Now, first is prioritizing activities. There are two main ways of doing this. One is total float priority, what you call. Those with the smallest float have the highest priority. Ordered list, ordered list priority. This takes account of duration of the activity as well as the float. Then comes Berman's priority list. Shortest critical activities, other critical activities. Shortest non-critical activities and non-critical activities with least float and non-critical activities. Handling resource conflicts, where same resource need to be needed in more than one place at the same time. It can be resolved by delaying one of the activities by taking advantage of float to change start date, delaying start of one activity until finish of the other activity that resource is being used on puts back project completion, moving resource from a non-critical activity, bringing in additional resource, increasing the cost. So these kind of issues helps you, or rather points help you to decide the priorities of and resource conflicts. Resource conflict basically means the same resource assigned at the same time to different tasks. How do you handle that? Then which is more important? Which has to be finished first? Now, when suddenly there is an importance for a task, you might need some resource person to join that particular team, which might affect some other activity. That is where conflict can happen. If everything is going as per plan, there is not going to be any conflict, no confusions, nothing. But that never happens. That is what we are coming to. Project scheduling issues and constraints. Goals: maximum utilization of resources, balancing cost versus schedule. So everywhere, this is very important. Maximum utilization of resources, balancing your cost, how much you're charging your client for that, and how much do you spend to maintain that versus schedule. Which do you give more importance? Whether you give importance to resource utilization or cost balancing or your schedule. That is always a challenging task. You must be able to put a balance between all these kind of activities. Now here you need to maximize percentage usage of resources, that is reduce idle periods between tasks. Need to balance cost against early completion date. Need to allow for contingency always. Resource scheduling may affect critical path. Scheduling resources can create new dependencies between activities. It is best not to add dependencies to the activity network to reflect resource constraints. Makes work very messy, right? Too much of complications can definitely make your work very messy. A resource constraint may disappear during the project, but link remains on the network. Now, if at all there is some constraint of the resources, but when you proceed through the project, this constraint might disappear because you might finish certain task earlier than scheduled date. So what happens? The resource becomes free. So then the constraint that you felt would happen will never happen, and so on and so forth. Amend dates on schedule to reflect resource constraints. Factors to be considered before allocating individuals is: one is availability, criticality, risk factor, training, team building, and motivation. Now, why motivation comes here is primarily because people in a team have to be motivated. Only then productivity will increase. A demotivated person will not be productive. That reflects on the constraints specified. Cost scheduled by cost profiling. Cost schedules are produced after resource scheduling. So you have estimated weekly costs, week number, cumulative costs. Significant costs in software development projects are person cost followed by infrastructure and support. Keep this in mind. Most important aspects of expenses here is: one is the person cost followed by infrastructure and support services that are provided. Scheduling is a balancing act. That is what I've been telling you. Experience tells you a lot. So you need to balance between these kind of. Right schedule emerges out of balancing resources, costs, and risk. Everything has to be looked into. So you need to look at the activity plan. You have to have a proper risk assessment procedure. You need to do proper resource allocation, and then you should also have a clear idea about your cost schedule. Only if you have a clear idea about all these four areas, you will be able to schedule things properly. So scheduling is a balancing act by juggling time, resources, and costs. Scheduling is arranging activities on a time scale, right? That is understood. Activity dependencies are charted on activity on node diagrams. Critical path is the path of activities from start to finish, whose float is 0. That means if at all something goes wrong in that path, it will affect the complete project. There is no float area. There is no buffer area. Critical path determines the duration of the project. If you look at the critical path, you will exactly get idea about how long the project will take. Managing activities on critical path is the priority of project manager, as delay of any activity on CP delays the whole project. So the project manager will always look at the critical path and the activities associated with that, because that is what will affect the project at any given point of time. Then shortening schedule of any project involves reducing duration of CP activities, which might result in a new CP. Commercial tools, example, MS Project have built-in diagramming and scheduling features. You have a lot of, it's not like earlier days. Today, you have a lot of tools available to help you in project management. And there are courses also in project management, which will help you to handle projects in a better manner. So with that, we are at the end of this session. Please answer the quiz and then you can leave. Just somebody message me whether it is accessible or not. The quiz is available or not.